Well, we are on the road with the electric RX-8. Currently, we're doing pretty good. Our alignment is off a little, but that was expected. Go up the top of the hill, check our temperatures of everything, and then turn around and go back down. I had to jump in here and do a voiceover for the video. This is a build montage for the Mazda RX-8 that I've been working on for the last 7 years. And what we're seeing here is the very beginning of the car, from removing the Toyota Avalon transmission to pulling the Mazda RX-8 engine. So we're throwing the old engine here, the subframe for the Mazda RX-8, I'm just mocking everything up now to get a good placement for the transmission so that it drives the axles in a straight line. Here I'm doing a little bit of welding. This is all it was, just mocked up. And later on, you will see that the transmission was changed. Now, what had happened is, later in the video, if you've seen at the very beginning for the test drive, I was using a Tesla Model 3 rear drive unit. Now, this is a big upgrade to what the car had originally had in it, because I've done it as a, and nobody has ever done it before. So we're using a hybrid transmission out of the front wheel drive car that I'm modifying the rear of the Mazda RX-8. So we've cut out a section of frame in the car to make room for this front wheel drive transmission to be mounted in the rear of the car. So as you can see, I've already got a nice area here cut out, but what had ended up happening is, after we removed the metal, we're fitting the transmission in, and I actually ended up having to cut more metal out of the car, which isn't ideal for doing a motor swap in anything, but given the circumstances of testing, and this is the very first ideal of let's make an electric car affordable kind of thing, just as something to play around with. So this started back in 2020. Right around March, I think, is when the original ideal had started with the car. Ended up purchasing a wrecked Toyota Avalon with a good transmission and engine. Poured the engine and everything out of the car, transmission, decided to put it in the Mazda because the engine in the Mazda was not running good. So this old rotary engine, that little, I think it was a 4-speed automatic, really sluggish and take off just like slow, and you really had to floor the vehicle just to get it moving. So it was really enjoyable driving around as a rear-wheel drive car, mid-engine, worked amazing, but I wanted to try this out. So we've done the Toyota Avalon transmission, and as I go through, I'm marking everything up. So here's the inverter placement for the transmission. I've got everything set up right above the motor, so all the wiring is just straight to the motor. There's no long runs or anything. And then here you're seeing me modify the transmission, because later in the video you'll see why. So I'm having to cut out some of the transmission to make room for the seats, if I put the rear seat back in it, to make room for it. And this had ended up turning into a So now that I've moved out of the way, you can kind of get an idea of what's going on with the transmission and the frame of the car. A little bit of room between the sides of the car here with this transmission being front wheel drive transmission. It's quite longer on the front between the axle and the front end of the transmission than a regular transmission on an electric car would be. But since this was a gas converted to electric using a gas hybrid transaxle, it doesn't fit. So this is all just to test and see if it works, and it done good for what it was. So here are the Toyota hybrid batteries. This is out of a 2018 Toyota Prius Prime. These are Panasonic cells, I think running at 25 amp hours. The 4-pack is 8.75 or 8.79 kilowatt hours. I'm running 2 of these batteries in a 3P60S configuration. This gives me roughly 252 volts at 70 amp hours. I have actually added a third battery pack to keep the 75 amp hours, but to bring the battery voltage up to 352 volts, making it just a little bit more efficient, giving roughly 22 kilowatts of battery capacity. Here you can see the bus bars and everything I've took off the batteries as I get ready to reconfigure the cells into the 3P 50S. So here we go, we've got all the modules and everything put together, and here we're charging batteries. So now we're going to run over to why we cut the transmission in the first place is right here. So this is just testing with the gas engine to see how the batteries and everything charged up. Done pretty good charging using a diode bridge rectifier. So I'm checking all the temperatures and stuff of the batteries, making sure nothing is over temping. Everything was good on this test, so I continued to go on through, verified this all worked. The motor turned. This is using a Prius Gen 3 inverter. I did drive the car around roughly 40 miles an hour is as fast as it would go, so I didn't really feel like leaving this motor in there. Done some tuning on it. The best I could do was 60, and it was pulling 80 amps doing 60 miles an hour on level ground. So something with my programming was off on the motor, so I just decided to skip all this and let's put a Tesla motor in it. So here's the battery breakdown of what I ended up with. I ended up with 9 modules, which turned out to be 57P, which was 235 votes for the battery. Regular Tesla's like 400 votes. So here we go. This is showing the diesel engine mount fixtures for testing the car as I progress with the build, so I have a way of charging the battery. At the moment, I didn't have a reasonable way of charging the battery without breaking everything down and individually charging each module group of 12 cells. So here we're just putting together some metal to mount a 10 horsepower Yanmar clone diesel engine to a Kia Optima hybrid generator. And I'm guessing that roughly 30 amps is going to be capable from the generator, and I'll get to why the amps is why we need to know this information in the video. So the amperage is basically your capacity, like holding a milk jug full of water. You got a full gallon of milk in the jug. You dump it out. It's empty. Now you put a quart of water in there. That's roughly 1 amp of capacity. So you want that jug full. So what I'm doing here is using the generator to refill my battery. And the amperage is how fast I can charge this battery. So a bigger cutout in the jug will allow me to put more water in the jug versus having a tiny nozzle, which would take a lot of time to put water into it. So here we're making a 30 amp generator. This is a Kia 2016 Optima hybrid generator and a 18 horsepower Yanmar diesel clone engine. Now I chose to use the diesel because it's a little bit more efficient. I've done some calculations and stuff and figured out that I would burn about half a gallon of fuel charging the battery from a complete flatbed battery. So this is a 75 amp hour, 235 volt battery using about a half a gallon to a gallon of fuel to fully charge the battery pack using this generator at 30 amps. And this is the max output of this generator that I can find for this style. We're outputting roughly 240 volts, which is about the limit of the generator voltage output using the dollar bridge. So I ended up using a couple inverters and some capacitors to bring the voltage up a little bit higher to make it more efficient to run. As you can see here, we're just doing some welding, trying to line up the frame with the engine so the generator will mount in line so I can use either a chain drive or a belt drive. I did end up trying a chain drive, but it completely wore the chains apart because there was such little the chain was actually shorter than what it's supposed to be, so it wore really fast. And there was some misalignments also. It didn't really work too good. So I ended up going back to belt drive later on to charge the car before we done the very first drive at the beginning of the video. And as you see here, we've actually finished welding everything up. Now we're testing the plate, make sure it lines up with the engine. Lines up fine. So all the test fits done good. Everything's in line. So I go ahead and drill all the bolt holes to mount the generator to the temporary engine assembly. And this is all leading up to a big moment. Here we go, we got a test drive of the transaxle. And this is tested at 48 volts or roughly 56 volts on a full battery pack. And I'm using a Gen 2 Prius battery and a electric e-bike controller as a test for this motor. And this is the Toyota Avalon motor that was inside the car just as a test. And as I'm showing here, this is a couple other ideals that I had just to test spin the motor because the inverter software wasn't working at the time. Still waiting to be written from Open Inverter Forum. Here we go, we've got 4 throttle forward. Make sure everything was lined up. It all done pretty good. Now we see the diesel generator finally inside the car. We're charging at 6 amps, 180 volts. I've cut the battery pack down to 180 volts so I get more amperage out of it. charging at 7 amps, just easing on the battery power. So here we go, we broke the battery back down, verify individual cell voltages, and now we've got the rectifier and inverter on the front of the car mounted, charged at 6.8 amps, 6.9, 5 amps on each phase wire. Here we go, we're showing the diesel engine that I'm currently working on for the Mazda. This is a Yanmar 18 horsepower 3-cylinder diesel. This is what my buddy made for me, Austin. Got his own little lathe at his house. He made a plate to mount the pulley to the back of the flywheel on this Yanmar so that I can put a full size roughly a 9-inch pulley on the back of this engine so I can spin the generators at the optimum speed for the diesel engine so we get the most efficient fuel burn we can. We're going to end up supercharging this engine to get it to rev up a little bit better so we have more control over the engine RPM and output as we go on throughout the build and testing phase. So here we go, we're doing a spin test of the engine. The engine's running, and I'm just checking the wire to run out on the pulley, and everything seemed pretty good. Of course, the pulley doesn't exactly have a true milled down surface on the inside, but as long as the outside was fine, that's all I was worried about. Make sure all the belts and stuff don't vibrate a lot. Here we go, we're putting the engine in with the tractor, and I actually ended up reversing the engine, so we've got the rear of the engine on the front of the car, so we ended up turning it around, so now we're facing the correct direction. There we go, we're getting ready to do some engine mounts. Send, cut, send for parts. Verified the oil pan is at their optimum height under the engine and the car. Now we're getting ready to do the engine mounts. So as I go on through here doing the engine mounts, I'm just test fitting to get everything kind of centered on where I would like the engine to be setting for the vehicle, and the rough ideal of where I wanted it set is about midways behind the front wheels, so a little bit further back than the stock RX-8 engine was, but there's plenty of room under the car for LS swaps. There's a lot of people who put LS engines in these cars, and there's plenty of room for a V8, so this little tiny Yanmar is perfect for this car because it's real small, lightweight. We're going to have plenty of power with the Tesla motor. We're looking at maybe 350 horsepower. The original RX-8 engine only outputted about 238 horsepower, but that was with a 6-speed manual transmission with a 6-port engine. This car originally only had a 4-speed automatic, which was a 4-port engine. If you look them up on Google, you'll see what I'm talking about the ports, just more air and airflow into the engine. So the automatics was cut down to like 200 horsepower. Hardly had any power, and they showed it. It's like driving a snail in salt. Extremely slow, but they was fun to drive. You could cruise them around all day long. Just have all kinds of fun. So here we go. We're welding the generator mount up on the engine just to have it secured. We've already test fit most of the mounts to figure out where we wanted to do the actual locations. I used a 3D CAD software to kind of mock everything up in the computer so I would know where all these parts needed to be mounted. So we had sand cut of some parts, and these are actually the metal that we had fabricated from them. Now we're doing the mounts from the car over to the actual engine. So after we fabricated the mounts on the frame, the subframe for the car, I'm setting up a bar. This is the first test fit for the actual engine suspension mounts. So there's about 30 to 40 minutes in between these shots here. I've tried to cut everything down to just a few seconds at a time, just due to the video being over 2 hours long. We didn't really need to see all the waiting time and everything getting cut, just an idea of what's going on here. So this is what I've done. I've ended up welding myself into a hole here because I had to cut a spot to remove my bolt. So this is not even planned. This is completely just out of the blue. I welded everything up and found out that I couldn't remove my bolt because the metal was too high. So we cut a small portion of the frame out. Now we're fixing to take everything over to lay it on the ground to finish the weld. So now we're verifying alignment between both sides of the engine mount, and it was off, so I ended up taking a little bit of metal off to bend it out, straighten it, thanks to EV West. I want to say a big shout out to Westside EV for supplying parts for this build. I do appreciate that. We're going through showing the generator that I'm using for the upcoming Yanmar engine, 3-cylinder diesel. It's going to be producing all of the power to supply the battery and this Tesla motor for an extended range. Here we go. We've got the Tesla motor, the old Mazda RX-8 for the subframe for the Tesla motor. We've got it flipped over and taken out parts from this one, differential, subframe, rear suspension and all. Showing a couple pictures of the what's going on with the car. Here we go. We're basically upside down now. This is a old retired RX-8. We got the subframe. Got it mocked up just to get an idea of where it's going to set on the car. And we've got the Tesla power cord for Model S, I think. And we've got the Westside EV open inverter control board with the harness. Thanks again to Westside EV for supplying parts. And we've got the control board mocked into the inverter. Got everything hooked up, ready to go for the test. Now we're getting everything situated on the car, the axles lined up. We've got the rear part of the subframe mocked up. We've actually ended up having to add a brace to be able to get the rear of the motor mounted in the car, which actually would be the front depending on how you look at it, but if it's been a Tesla motor, it's the rear. We've got some adapters here welded up to make the Tesla axles adapt over to the Mazda RX-8 axles. We're going to possibly need to get some of those made. Here we go. We've got a test after axles have been welded. We're using 56 volts, lithium battery pack. Test spin the motor. Test spin was okay. Regen slowed down the way it's supposed to. So now we're going to go over to the Mazda. Now we're removing the Toyota Avalon transmission. Got a couple photos. I didn't really get a video of this because it was real cold. Me and my cousin was pulling everything out of here, so I ended up having to cut a access spot in the trunk. Here we go with the old subframe. This is the old Toyota Avalon we've seen at the beginning of the video getting mocked up in the car. So now Now we're showing the wiring harness that I made for the Tesla motor. There was only about 10 wires required to make this motor run. We've got the motor mocked up under the car, mounted. We still have to work on making some control arm brackets. Probably going to buy a Harbor Freight pop bender and some tubing to make a racing subframe for this car, a racing style, just open subframe with control arms. Here we go. We've got the motor mounted under the car, subframe welded, everything's bolted in. We've test fitted to make sure all the alignments and everything on the car was okay, to put it together, to assemble it so we can test it. Later on in the video, you'll see that the alignment was off because I didn't really do much alignment to it. And now we're getting ready to do a test drive, so we're welding a water pump in and reservoir for the motor and inverter. We've already got the diesel engine mounted in the car. We're just waiting on a couple more parts coming for it. That'll be a completely separate video of testing the diesel Yanmar engine, charging the car while driving. There's a lot of testing that's got to be done to that system just to verify that it's going to operate correctly. But now we've got the water inlets and hoses attached to the radiator, and this is a full 2018 Prius Prime hybrid battery pack in good condition. So I ended up testing the car with this battery at 280 volts, I think is roughly the voltage. Because I took one module out, it was damaged, had a bad one of the battery cells was damaged, so I didn't want to use it. Now we've got the car subframe hooked up with the battery. So here we go. We put the battery in the trunk. Subframe is real good. We ended up using noise isolation to cover the hose temporarily. Got a 12-volt battery back there, deep socket around the car. Currently we don't have an engine for an alternator, so that's all going to be later on in the video. We're getting ready to drop the car down, and now we're testing with the Yanmar 10 horsepower diesel, charging the car roughly. Alright, we're about to go on the maiden voyage, the Mazda RX-8. We've got our digital gauges here set up, ready to go, battery voltage, and we're going to go up the road. We've got an amperage meter in the back to read the amps. Make sure we don't go above what we're supposed to. So here we go. At 30 ounce. It's not too bad. I think it'll work out really good. Run that yellow line all the way through here. My alignment is off a little. Well, we are on the road with the electric RX-8. Currently, we're doing pretty good. Our alignment is off a little, but that was expected. Go up the top of the hill, check our temperatures of everything, and then turn around and go back down. All right, we're driving, pulling about 50 amps. About 115. Ease off the throttle. 20 amps right there, cruising at 40. My old motor pulled about, I want to say it was pulling 80 amps, just cruising at 40. And this thing's barely doing 30. 60. It's temporarily hit 100 just gassing on it.